Good day everyone, my name is Jasper Tom Isiderio of BSEC3A1 and today we will have a tutorial about flip-flops in digital electronics. But first, we need to understand what is a flip-flop. So a flip-flop is a bistable device, and when we say bistable device, it means a device which can store a bit of binary data with one state representing low or 0 and other state is high or 1. So why is a flip-flop considered a bistable device? That is because it consists of digital logic circuits that can be in one or two states, which maintains that state indefinitely until an input pulse called a trigger is received. This means that the output from the device can be one of the two possible states and will remain that way even after input signals are removed. It will only change when commanded. So there are different types of flip-flops with also different usage and purpose. But what we will discuss today is about T flip-flops, also known as toggle flip-flop. So here is the logic symbol for a T flip-flop. This type of flip-flop changes its output on each clock edge, giving an output which is half the frequency of the signal to the T input. So this right here is the trigger, and right here is our clock. The Q here signifies our output, and this Q prime signifies the inverse of our Q, which is our output. It means that this is the inverse of our Q. So to expand the diagram further and also to let us visualize how the circuit works, here is the logic circuit diagram of the T flip-flop. So as you can see, this is the modified JK flip-flop circuit. And what we did here was we shorted this top one, which is this is J and this is K. So we shorted that and we connected it to be the trigger right here. So it will be the trigger of our circuit. So we only used 4 NAND gates. 2 of them are 3 inputs and the other 2 are 2 inputs. So the connections goes like this. As you can see, the inner part of our 3 input NAND gates are connected together. That will be connected to our clock. Now the middle inputs of our 3 input NAND gate are gonna be connected together or shorted. That's gonna be connected to the trigger. The outer input of our 3 input NAND gates are gonna be connected crisscross to our outputs, where the upper 3 input NAND gate will be connected to Q prime and the lower 3 input NAND gate will be connected to our Q. Same thing happens to our second NAND gate that has 2 inputs. Their first inputs are connected to our prior NAND gates, and another input is going to be connected crisscross to our output Q and Q prime. So to explain how this works, this is the truth table for our T flip-flop. So right here, as you can see, when clock is 0, any value that we have on our trigger, our next state will be memory since our flip-flop is not operational. So next, if our trigger is 0, our clock is 1, it will be just the same. We will be having memory or hold. So next, if we both have trigger that is 1 and our clock is also 1, then we will have what we called as toggling. So using our truth table, we can now derive our characteristic table. So it will be right here. So as we can see in our truth table right here, we will use this to derive our characteristic table. So now as we can see, our Q is 0 and our T is also 0. As we can see, if T is 0, we will just have to retain or hold it. So it will be just gonna be 0 copied from our initial output to our next output. So next, if T is 1, right here, we will look at it, our truth table. If it is 1, we will have a toggling effect on our next output. So if our prior output is 0, our next output will be 1. It will become reverse. So next, if our T is 0, as we can see in our truth table, if it is 0, it will just retain like that, 1. So next, if our t is 1, as we can see, truth table, it will toggle. So if our output is 1, it becomes 0. So using our characteristic table, we can now derive our excitation table. Okay, so just like that, we use our truth table to get our characteristic table, and from the characteristic table, we use that to get our excitation table. So as we can see, it is just like almost the same to our characteristic table. The difference only is we have the trigger on the other side. It means that we are predicting the input if we have a set of given output. So all we need to do is observe the characteristic table, and using that, we can now fill up our excitation table. So as you can see, here the values are just the same, but they are just having different order or sequence. So I guess that is all for our excitation table. Now let's go to our simulation. Okay, so this is the electronic workbench diagram for our T flip-flop right here. So we will use this to simulate and also explain the operation of our circuit. Okay, so this diagram is the modified version of the master slave flip-flop having two asynchronous active low inputs. So as you can see, we connected J and K terminals. That's gonna be our trigger. That's just like what we talked prior. So as you can see, we added preset and our clear right here. That's directly connected to the NAND gates of our outputs. This forcefully makes our output to be high. Okay, so um, now we will try to run the circuit. Okay, so as you can see, when we turn on the circuit, our Q and Q prime continuously blink. It means that our circuit is not yet initialized and it's not toggling yet. So what we will do is we try to turn off the preset right here. So as you can see, Q stop toggling, blinking I mean. So what we will do is we will add a pulse in our clock. As you can see, Q prime stopped blinking also. So to initialize our circuit, we just stop the blinking. So to initialize our circuit, we will add our trigger, and also we will turn on our preset. So as you can see, if we add the pulse to our clock, our circuit toggled, as you can see right there. Okay, so we will try it one more time. We will input pulse to the clock, 1 2, as you can see, it toggled. So you can do this continuously and just leave everything else and just put the pulse to our clock, and our circuit will continuously toggle. Okay, so that's the toggling effect of our T flip-flop. Okay, so that is all. Thank you for watching.